This right here is called the quadratic formula, and the quadratic formula, I'll put QF. Quadratic formula solves quadratic equations. Quadratic formula solves quadratic equations. So if you have a quadratic equation, let me just take an easy quadratic equation. Plus 4x plus 3. I chose that because I know that that factors into x plus 3 and x plus 1. Right? So I know my two solutions to this. Remember, there's up to 2 real solutions. For every quadratic formula, there's up to 2 solutions. That's what this squared tells you. The power, the highest power, the degree of a polynomial tells you the maximum number of solutions that you have. In fact, it tells you the exact number of solutions you have if you're counting complex solutions, imaginary solutions, and you're counting multiplicity. Does that make sense? Mm-hmm. But it also, those things can relate to real solutions, which if you have a real solution, it relates to, when you're looking at your graph, it relates to this right here. And that's exactly what we have. We have this graph because this x equals -1, or sorry, -3, and x equals -1. Those are the two real solutions, -1 and -3. So let's redo this problem, but now let's solve it using the quadratic formula. So if we solve this quadratic equation, if I solve this quadratic equation using the quadratic formula, a is 1, b is 4, and c is 3. So let's do it. X equals -b, so -4 plus or minus the square root of 16 minus 4 times 1 times 3 all over 2 times 1, which simplifies to -4 plus or minus the square root of 16 minus 12 is 4 all over 2. Square root of 4 is 2, so it's -4 plus or minus 2 over 2, which means -4 plus 2 over 2 and -4 minus 2 over 2. This one right here equals -1. This one right here equals -3. There are my two solutions, just like I solved it with factoring. Notice factoring was easier because, well, if you know how to factor and if you understand what it does, it's just a quick way to get to those solutions. But the quadratic formula will always work, assuming you do it right. People usually make mistakes here. But let me point out again, what this is right here is called the discriminant. The discriminant, if it is positive, means that there are two solutions because you have a plus and a minus there. So you have to have two real solutions if the discriminant is positive. If the discriminant is negative, what if if this was like a -4, then we would have an imaginary solution. In fact, we would have two imaginary solutions. And that translates to the graph. The graph would look something like this, where it doesn't go through the x-axis. That's what the interpretation is of a negative discriminant. And if the discriminant was 0, let's say the discriminant was 0, if this right here was 0, then this plus or minus wouldn't matter because adding 0 and subtracting 0 gives you the same answer. And all you would have, notice what you would have. You would have -b over 2a. Sound familiar?
It's the vertex.
It's the vertex. And where is the vertex? The vertex would be your solution, your only x-intercept, which means it would do something like this. It would bounce off your axis. And that's what would happen if you had a discriminant of 0. So that's what the discriminant is and how it relates to graphs and solutions to a quadratic equation.